Exercise 21, page 42, on laws of indices, or exercise 19, page 41 if you're looking at the old textbook. Question 1 here, simplify this expression. I'm going to run through this problem, and at the end will be another one for you to try exactly the same, so have a look at that. So to do this one, I'm multiplying two expressions together. This expression multiplied by this expression. So each expression is separated by a bracket, but in fact what we're doing here is multiplying all the terms together. This represents one term and another term and so on. So I'm multiplying all these terms together effectively, which really means I don't need the brackets. So what do? Well, I use the laws of indices, because I don't know what base x is, but I know it's the same in both of these. So I've got an x squared times an x cubed, so I add the powers. 2 plus 3 is 5. Similar for the y's, y cubed times y, add the powers. 3 plus 1. Remember, if y is on its own, it means to the power of 1. And similarly for the z's. So this simplifies to x to the power 2 plus 3 is 5. Y to the power 3 plus 1 is 4, and Z to the power 1 plus 2 is 3. And now I'm going to put in the numbers and evaluate it. So I'd rewrite this expression, but with the values put in. So x is a half to the power 5, multiplied by 2 to the power 4, multiplied by 3 to the power 3. Again, I've not bothered to put the multiplication symbol in between these. No symbol means multiply. Then I can work it out. You can either do this on the calculator or in your head. So if I pause while you work it out, the answer's at the end in the textbook. Note that you could use the laws of indices again to help you with this answer. You can work it out on the calculator, but if we look at this that I've written here, as a start off to the solution, a half to the power 5 is the same as 1 over 2 to the power 5. So we can then use another law of indices. Remember, x to the a divided by x to the b is the same as x to the a minus b. So the base is the same. They've both got base 2 in here. So actually I can do 4 divided by 5 is the same as 4 minus 5 is minus 1. So that's 1 over 2. Well, it's effectively what you're doing is you're cancelling out the 2 to the 4 on the top with 4 of the 2's on the bottom, leaving 1, 2 on the bottom. So this cancels out to 1 over 2 times 27. These 4 2's on the top cancel out with 4 of the 2's on the bottom, leaving just 1, 2. So it ends up just being a half of 27, which is 13 and a half. Which should agree with what's written in the textbook. Having had a look at that, you could now try this one. So pause the video, try that one out, and then when you've had a go, have a look at the solution. Here is the solution. The simplified version is a cubed b to the 4 c to the 4, and then putting in the values and working out. Notice again, 1 over 2 cubed is the same as 1 over 8, and 8 cancels out into the 16 twice, so you end up with 512. So look for those simplifications. Don't automatically put a half into the calculator and cube it. Good practice.